Good day, guys. Alright, so in this video I want to talk about two things: the principle of energy conservation as well as the work energy theorem, right? So, and then we'll do one example. Alright, okay, so first things first, let's look at the principle of conservation of energy. So the principle of energy conservation merely says that energy cannot be destroyed cannot be destroyed, nor can it be nor created. Okay, so these energy that we're talking about, they can however change form. So you can have, for example, potential energy to kinetic energy, or maybe chemical energy to electrical energy, say in batteries, right? So how do we put this into mathematics? Well, because energy cannot be destroyed or created, the amount, right, the summation of all the types of energy must be constant. Okay, so there is no change. So that means that there is no change in the summation of all the energy. So if I have, for example, kinetic energy and potential energy, and I convert that into just kinetic energy, it will be the same. Okay, so the summation of kinetic energy before and after must be the same. Okay, all right, so let's look at the second part, which is work energy theorem. So the work energy theorem merely says that the work done is equal to the kinetic energy. All right, and this is fairly obvious if we consider that work done is equals to F dot S. Therefore, the unit that we'll have is Newton meters. And then, so for energy, for kinetic energy, we take this equation, half mv square, and what we will have is kg m square s negative 2. And then just remember that F is equals to MA and has the units of kilograms m s negative 2, right? And this is multiplied with m. So what you have is kg m square s negative 2. So these two units are the same. So in physics, when those two units are the same, they are equal, they are the same thing. So what we can say is that the work done by constant force is equal to the kinetic energy. All right, so that's what the kinetic work energy theorem says. All right, so we have covered work energy theorem as well as the principle for conservation of energy. Now let's look at a question that we can apply the principle of energy conservation. Right, it says a skater of mass 80 kilograms at rest, so it starts at rest, skates down the ramp from a height of 8 meters. Okay, so the initial height is 8 meters from the ground. Calculate the velocity of the skater when he reaches the ground level if the amount of heat his tires has generated by then is 300 joules. So we have heat. Okay, so how many types of energy that we have? We have the gravitational potential energy, right? So we have EGP, which is mgh, right? And then we have kinetic energy, because we have some velocity, kinetic energy, half mv square. And then we have heat energy. In this particular question, you are given the value, which is 300 joules. Okay, so let's look at the before and after. Before, so total energy before, I'm going to use initial, must be the same as the final because of conservation of energy, right? So before, it has no velocity, so there's no kinetic energy, as there's no heat generated yet. So you only have gravitational potential energy. Okay, once the skater starts moving, heat energy is being generated and he gains velocity, he gains momentum, right? So at the ground level, you no longer have EGP, right? You no longer have EGP, so you are left with kinetic energy and the heat energy. All right, so we can expand this. mgh equals to half mv square plus 300 joules. Then we can rearrange that to get V equals to mgh minus 300, and then we have, okay, we divide it by m and then we multiply it by 2 and we will get V square, right? And this will be approximately 149.46, so approximately 149.46. all right, and then we're looking for the velocity, so v, we can just square root that value and we will get approximately, again, 12.22 meters per second. All right, so we have calculated the velocity of the skater as he reaches the ground level. All right, so that is the example that we can use. The general strategy is that we ask ourselves what sort of energies are involved. Here in this particular case, we involve gravitational potential energy, we involve the kinetic energy and heat energy. So once you have determined what sort of energy is involved, then you write down the equations for each type of energy. All right, and then you have to ask yourself, when does that type of energy is involved? Is it in the initial state or the final state? Right. So as we can see here, in the initial state, only gravitational potential energy is involved. And then that gravitational potential energy is converted into kinetic and heat energy, which is why they sit at different sides of the equal sign. And then once you've done that, it's merely algebra from there on. Okay. Just to clarify here, I have m equals to 80 kilograms. I have g equals to 9.81, so kilograms meters per second, and then I have height equals to 8 meters. All right. Okay, so that is all for this video. In the next video, I'll be talking about chapter 6, circular motion. I'll see you then. All right, thank you very much.